Perfect. So hello, everyone. Welcome to this presentation. It's our pleasure to present our research to you today, here at a research group at UCLA. I'm Shadi with my colleague Pavan. Pavan will be presenting the second part, which is about our exciting results. Our topic is about an AI pipeline for discovering narratives in social media and the news, and also characterizing conspiracy theories.
I want to say, if you have a question, please post it in the Q&A or the chat. And first, I want to thank the presenters, Shadi and Pavan from UCLA, and also thanking Angel Faria, the organizer of this event, and many also attendees here from URI and from Brandeis and from different institutions here. This is part of Rhode Island AI meetups. This is, I think, our fourth year. This is event number 18 around AI and its impact on society. So I'll let you work. This is very, very hot topic in terms of what's going on in the US and worldwide in terms of conspiracy theories. And this will help us really kind of understand the logic. So please go ahead.
Thank you. Thanks for having us. So the study of conspiracy theories and stories on social media has an equivalent in legend studies. We view social media as a global storytelling platform that everyone is talking about their own topic, and each post is a piece of a story or a narrative that involves actor or actants, characters, and their relationships within each other. The emerging narrative is broken up into bits and pieces strewn across thousands or millions of posts. And our work is a collaboration between a humanities scientist and a computer scientist to design a computational puzzle solver that is able to put together all these pieces and identify all those actors or actants and their relationships, and give us the whole picture of and reconstruct the narratives. Our research topic is about creating a narrative miner that acts as a social mirror that can show us what's going on. Because as we know, no single person can go through billions of posts on social media. And at the same time, narratives are emergent, and they can form fast over a matter of days or even hours. So there is a constantly churning computing engine along the axis, including real life events, news media, social media. And we have designed an AI pipeline that can sort out these narratives from all these sources and reflect them back to us, to society and individuals. In the past few months during the pandemic, we observed a lot of conspiracy theories. We have had previous research about anti-vax movements, and we had about Pizzagate and Bridgegate fake news. But these past few months were just like a history in conspiracies. For example, this virus is related to 5G network, or COVID-19 is a bioweapon. Even some people calling it a hoax, and many other more. So these conspiracy theories can be scary because they are important for us. They are at the core of fake news. They have a real life impact, and people are acting according to these conspiracy theories. So that's why we are interested in automated discovery and understanding of social narratives, of these conspiracy theories, or in general, the emergence of social narratives. That conspiracy theories is a big example. Now, getting back to the study of narratives and folklores, we see conspiracy theories as a fictional narratives because they have the potential to cause harm, and they have found a way to welcome home on social media, where free from moderation allow like-minded individuals to converse and they develop their own theories collaboratively based on a shared hidden knowledge. And they propose actions to counteract the threats they uncover. Now, how we're designing this automated narrative miner. So first of all, we need to define a machine learning model, a generative model, where we want to formulate it as a machine learning problem. So we start with the assumption that narratives follow an underlying compact generative models, and these models have the abstractions of human thought processes. So on the other hand, social media posts are the output of these models because they're the world outside reflection of human thoughts. And so our task is, given such models, estimate their parameters from the data or those social media posts. So fortunately, how the narratives are generated has been studied before. Summarizing stories of thousands of storytellers and legends and presenting these stories in an organized fashion has been an open problem among folklorists. These are the examples, those simple examples of narrative theorists. The representation of narrative as a network graph has been a study topic in these studies. Inspired by Propp, Leonard, Greimas, Tanger-Lenny, we use a narrative framework model which comprises of actants, interactant relationships, and domains. Actants, which are those nodes or those points in our graph, are peoples, organizations, places, and the things that form the nodes. And interactant relationships are pairwise or multi-way relationships that form the edges of this graph. And finally, all these interactive relationships are context-based. For example, they can be in health, politics, power, corruption, religion, etc. And these models have semantic meanings where so we reach out to the story models that they have developed. One of the common story models has a narrative thread structure where people studying legends, story plots, and folklores have studied this kind of structure and defined their components that you can see here. So each story in this model is comprised of orientation, which is the role of the node, the who, what, where, and when. Second, a special node in the graph called threat, that is threatening or disrupting the orientation. And the third one is the strategy, which a proposed solution or action for averting or counteracting the threat. And finally, the result, which is the outcome of applying the strategy to the threat. So our next question here is, how well is this generative model? By model, I mean, so this is a model, so it has to be related to real life. And how well does it fit in the narratives that we are studying on social media? So traditional narrative theorists have used this model. Their challenge was, given a text or documents, identify these structures, those orientation, thread, etc. So what they would do is they manually create networks and or the ground truth that drive those documents with these constraints, such as the narrative, the complete narrative exists in one document, a single book or a story or a novel, and which means that the writer has written the book and is responsible for the structure of the network. But the challenge is, the narrative theorist challenge was to reverse engineer the narrative model. Now our question here is, does this model work for social media, and can their estimation be automated instead of the manual work? So The question is, how good is this model for social media? It's more challenging because multiple narratives and stories coexist on social media. Everyone is talking about their own topic. And we don't have a single document. So the underlying narrative graph is scattered over millions of posts or even more. However, there exists this opportunity here, and it's a window into human decision-making process because they pick those texts from the characters in their mind. So we observe how it's formed over time, and so it's required, therefore what is required here is a definition and estimation of those complex networks that are driving the emergence of these conspiracy theories. Now, recall that we do not have access to a single document that represents one underlying narrative network. Instead, we have access to millions of unstructured posts. So we needed to create a generative model for a post at a time. What we do here, our generative model is as follows. A user first fixes a domain, so fixes their own topic, or a context from a part of a narrative graph, and then which kind of narrows down to just a particular part of the network, and then samples nodes or those characters from that graph, and then their relationships associated to that subnetwork. And finally generates the text connecting all those nodes, all the dots together, and posts that on social media. So now that we have a model for a post in terms of an underlying network, our job is to go from a single post to a network. But this estimation process has challenges because users generate posts with different words or phrases. We can have many words for just a single phenomenon. So there is no, and at the same time, there is no ideal encoding of these phrases. We cannot say there is like just only one representation for all these various formats. So we have no standard method also for similarity measurement to see how similar two words are. So one actant may appear in various domains with different phrases, different mentions. So our solution, our pipeline starts with sentence level, followed by aggregation using new natural language processing tools that are helping us with the semantic encoding. So now, going back to our methodology, more technical, our proposed solution starts with sentence level relationship extraction. For all the sentences that you see here, the sentences are coming from the posts, and the module here creates this table that has 3 different main parts: arg1, verb, and arg2. For example, for the sentence, the argument is that 5G causes coronavirus. We get these main triplets, 5G connecting to second argument coronavirus with a verb phrase causes. So the output of this part is, given all the sentences, find all these relationships or triplets that are connecting different noun phrases with the verb phrases, and they come with their own type that I will discuss in the next slide. So we're trying to capture these pairwise relationships through the syntax structure. We break down each sentence into their subject, verb, object, and other tags, and we use them to create that table. And despite the existence of different tools such as Reverb, Oli, or Clause.ie, we have improved Stanford Parser package that it's an information extraction, and it's optimized for aggregation. So our pipeline includes, the relationship extraction includes many types of relationships. For instance, subject, verb, object, or subject, verb, preposition. So now, after extracting triplets or relationships from their posts, we take the first step to discover the actants or the nodes in our narrative graph. An actant is an entity or a group of entities captured in those arg1 or arg2 noun phrases in the first table that serves the name the same or has very similar semantic rules in one narrative graph. Our journey to discover the actants starts with entity discovery. We take advantage of named entity recognition Python package that is specific for discovering entities that are belonging to a predefined entity class. For example, the name of places, the name of characters, or some specific names. Sorry. And then after we have find all these nouns, we finally rank these entities based on their frequency they appear or how popular they are in our data set. So in the upper table here, you may see the ranked entities for our case study data set, which was for coronavirus. The actants themselves have these actants, they have a hierarchical structure based on different contextual roles. So the actants dealing with different contexts can be considered as a superactant. So, for example, virus, coronavirus, COVID-19, all these others, they tend to co-occur a lot in our extracted arguments or sentences. So we group them as, we group corona and virus as two highly related entities, which they have almost similar context roles. So after we have grouped this, we call them supernodes. We try to break down to make them specified in our graphs. So in order to break down the set of phrases that belong to a supernode, we use the encoding representation followed by unsupervised clustering. Clustering groups the similar ones into a single cluster. Each cluster is called a subnode or the same context subset of a supernode. For example, looking at the table here, one cluster has the phrases such as huge decrease in flu death, the regular flu death, and the other phrases as you may see here. And for each subnode, we use after we have discovered all these groups of phrases, we use a scoring system that is based on, that is a numerical statistics which to reflect how important a word is, of these words to label them. So in the first group, you see that death and flu are two important words, whereas in the second one, flu and common are two important words to finally represent this cluster, which we call them the label of this cluster. Now, in order to find the semantic encoding of a phrase, we use word embeddings. These word embeddings, they provide us a vector for each phrase. So it's a transformation from text to a set of numerical vectors. And we use a language representation model called bidirectional encoder representation from transformers, or in short format BERT, that converts a phrase or a text into 768 dimensional vector. And it's well trained and provides encoding for a variable length text phrase. Finally, these embeddings allows us to compare phrase meanings using cosine similarity. So here is a summary of our methodology for actant discovery, or those nodes in our narrative graphs. In first step, we find all those entities and we rank them according to their frequencies. And then next, we group these entities to find the almost similar context one called supernodes. And then we break them down into these smaller same meanings ones called subnodes. So, so far these subnodes form the nodes in our graph. Next, for each subnode, we aggregate the sentence level relationships. For example, here, Bill Gates acts as a subnode and then has all these relationships to other noun phrases, right? So, for instance, Bill Gates is connected to coronavirus with the edges as labeled as created, patented, funded, injected, programmed, like as we see here. So there has been different posts on social media that they talked about Bill Gates, and they have related Bill Gates to coronavirus using these verb phrases. And we show them in our graphs. So the underlying structure of social media consists of numerous stories, because everyone is talking about a different topic, and we see more than a lot of stories evolving at the same time. Now, we have this big picture, and we are interested in dismantling this network so that we get the same context parts of this graph. So we use an algorithm in graphs called community detection, where it helps us to find the dense parts of this graph. And we have modified that algorithm to develop a statistical method using the Newman community detection algorithm to find the communities or a single conspiracy or a single story in the whole picture. The color coding here represents the result of our algorithm. That you can see here, the colors, the same color accounts for the one dense part of the graph. So finally, here is a flowchart of our pipeline that includes 21 modules, integrating Stanford parser, named entity recognition, semantic role labeling, BERT embedding, and many more. It's also published on GitHub for public use. And now I invite you to the exciting results that Pavan is going to talk about.
Thanks, Shadi. I'll just share my screen now.
Mm-hmm.
Can you see my screen, Shadi?
Yes.
Okay, great. So hi, everybody. Thank you, Shadi, for that wonderful introduction to our pipeline and a bird's eye view of all the different interlocking tools that are used in trying to get accurate networks that represent conspiracy theories. Now, before we get started with the results and discussion, we have to first look at the data sets that we're using for this, this analysis. Now, one of the first applications of this pipeline was for the conspiracy theories surrounding that are commonly called Bridgegate and Pizzagate. We'll talk about those in a little more detail in the next few slides. For these two conspiracy theories, we looked at some of the archives by the UCLA library, Reddit, news articles, and you can see the details about how many posts and sentences we had for Bridgegate and Pizzagate. Now, today's results, as in today's rendition of what we have done in the past, with some improvements, accounts for conspiracy theories such as some of the reasons people stormed the Capitol, conspiracy theories surrounding COVID-19. And for this area, and today we use dynamically sourced internet scrapers across a variety of social media platforms, including, as you see here, YouTube, 4chan, Reddit, Twitter, and we also use news at scale provided to us by GDelt, which is a fascinating resource for anybody who wants to work on news, and we highly recommend using that one. In particular, how do we target conspiracy theories? Well, we just search for conspiracy theories. So we go to YouTube, 4chan, Reddit, and Twitter, and we search for common threads, common boards where people post about conspiracy theories. One of our collaborators, David, is currently integrating even 8kun, which is a more out there extremist group that has even more conspiracy theory details about QAnon and about its current forms and beliefs. We'll talk about QAnon in the results when we get there. So this is an outline of the data set, and every day we scrape large amounts of data in the thousands of posts, at least 5,000 posts every day today, targeting conspiracy theories that are out there, and we run this end-to-end pipeline to generate networks. The front-end version of this will be coming out shortly, so please stay tuned for that. Before we get into the results, some disclaimers. As Shadi mentioned, what we provide here is merely a mirror to what is already out there in social media. This doesn't really mean that we're here to say, based on our network, that okay, this network is talking about something that's definitely a conspiracy theory. No, we are merely reflecting unstructured text in a never seen before structured manner. And this structure can connect disparate domains and really provide value to an end user who, as Shadi mentioned, will not be able to read billions of posts or access all the data sources at the primary level. So in some sense, this mirror is a way for introspection and judgment. So when a user looks at an unstructured social media post, now instead, if we had something like a mirror that really looked at the full context of what this particular post is talking about, the context in which it exists, the support on which it exists, whether it's connected to trustworthy sources, who are the different actors in play. This is really where our mirror might come in handy, because the mirror basically connects entities with valuable relationships. So in some way, it's an explainable AI where you can trace every figment of our network back to its data source and really infer from it what the full scale of this conspiracy theory or part of conspiracy theory is. It might also help in things like counter advertising when you look at the vaccination programs and advertising that's going on right now for the COVID-19 pandemic. The government is being very proactive with having very good publicity and advertisement in order to promote this vaccination program as a direct opposition to the anti-vax movement. And having this kind of a network will perhaps prime agencies to predict and ensure that they are on target with what's going on and how to prevent real-world catastrophes from occurring because of these emerging conspiracy theories. So here's one of our first networks that we wanted to show in this presentation. It's the narrative network of Pizzagate. Now, for those of you who are not aware of Pizzagate, it's basically about Democrats being associated to Satanism, and it resulted in real world actions that were that were very troubling, to say the least. And gunmen basically stormed a casual dining area, and in the attempt to uncover this Satanistic ring, in some sense. And what we show here is, again, as I said, our network is very explainable. And so for every actant that we discover in the final network for Pizzagate, subnetwork for Pizzagate, if you will, we associate these actants or nodes to their relevant subtopics. So these nodes in this frame are associated to democratic politics. These nodes in this frame, Podesta Brothers. The nodes in this frame, casual dining. In this frame, Satanism. And in this frame, WikiLeaks. And in the aggregate, you find a network that seems pretty well connected. Now, the fascinating thing that we observed in some of these conspiracy theories is, now if we remove WikiLeaks, which is one of the sources for this aggregated network, we removed WikiLeaks now, as you can see here. There's no longer WikiLeaks. And we look at the network that now exists with just the remaining frames, the nodes from politics, the Podesta brothers, casual dining, Satanism. And you immediately see how the aggregate network suddenly became so disjointed. It's one of the things about conspiracy theories, at least the first ones that we observed in Pizzagate and Bridgegate, that these conspiracy theories rely on a single, probably dubious source of truth, that without which the graph falls apart, the connectivity goes down, and what initially seemed to be a well-constructed, almost nearly fully connected network is now just many disparate smaller networks that don't really make sense on their own. Here's a more in-depth understanding into what the nodes really talk about, because you couldn't see the nodes in the previous two networks that we showed. In particular, this network that we show here is about Bridgegate. Now, Bridgegate is it's a fairly common conspiracy theory that involves Chris Christie and a bridge. But if you see here, all the edges have semantically justified labels. In particular, we highlight that Chris Christie endorsed Paul Nunziato, questioned Christina Rena, pressured, and you know, we have different entities or actants like Mark Sokolich, Rockefeller Group, David Sampson, Bridget Ann Kelly. These people are not the first, at least you won't get this whole world of actants connected to Chris Christie without having such a network visualization that is the result of our pipeline. It is very difficult to understand Bridgegate if we cannot really trace down all the actants and how they're all connected in an explainable way. And that's what we want to show in this result here, in that really that's the purpose, in that we can provide structure to what is otherwise seemingly unstructured conspiracy theories floating around in social media over many, many posts, where each post only has a subset of what the full conspiracy theory talks about. So going back to what we do in our current implementation for today's conspiracy theories, which some would argue is just an emergence or a transformation of the previous conspiracy theories, such as Bridgegate and Pizzagate. We realize again that conspiracy theories and generally any narrative in general today seems to be having this kind of a feedback loop between news and social media. Some things are reflected in the news. These events are taken and reflected back in social media, and that keeps going on and on. And at some point, they result in real world events and happenings. As you can see here, the yellow line says that this feedback loop can trigger real world events. There were cell phone towers burned down in the UK because a conspiracy theorist such as David Icke said something about 5G and COVID-19 and attaching those two. And so there can be real world damaging events because of unfettered and undetected conspiracy theories that share network properties that we want to examine. So ultimately, what are we doing, right? We're looking at the news, we're looking at social media, and of course there is some information loss. And the goal is, well, hey, can we build an understandable knowledge representation that is structured and really describes a narrative of disparate conspiracy theories that exist in these corpora. Here's just a snapshot view. It's so similar to the photo that Shadi showed earlier. It's a high-level view. It looks cool. It shows different colors for different communities. We want to emphasize here that our network isn't just one big blob of this massive network. Rather, because of our community detection and our pipeline that occurs before it, we are able to extract different contexts and different communities. And that proves useful if we want to really look at particular networks within this larger connected network. It's because of the community detection. Here's a more recent result that we found in our mining. Again, this figure was created by David Chung, who works with us at the narrative modeling group. It was extracted on the 18th of January. And you see the node here, QAnon. And the point that I wanted to really emphasize here is the connectivity of the actants and the different conspiracy theories that just this one small subnetwork has managed to dig up for us. So QAnon is connected to different subnodes, as Shadi has talked about in the methodology. Each subnode now talks about a disparate conspiracy theory. It's really fascinating. So you look over all the way over here, you see that this subnode is talking about Joe morning MSNBC. You just put this on Google and you find out, well, hey, Trump claims that Joe Scarborough was instrumental in the death of a young marathon runner. And you see that Joe is a Republican and staunch critic of Trump. And then you see another node right here about the 911 and moon landing, and then about how it's a doctored video. And for sure, I mean, that's a very famous conspiracy theory, and that seems to be always attached, whether it's by 2 or 3 degrees of separation away, to QAnon. And you can go on to the third conspiracy theory here about Korik's comment. She was a person who made the derogatory, apparently, comments about deprogramming GOP supporters on Jeopardy, and her profile and her background was covered extensively among conspiracy theorists. A little bit about Adam Schiff in point 4, about being arrested late last year for colluding with the Russians. And of course, big tech being responsible for unbelievable vote counts in Georgia. And about how, you know, JFK has actually been hiding in Pennsylvania. And this one, part 0.7, somehow feeds directly from Pizzagate, where, again, the Biden family has been associated to pedophilia. Let me just get my charge here for a minute. Thank you. So in our current work, again, here's another representation. We were trying to provide different views to the end user. Here's one of them where you see the virus that's connected to cells, waves. And in particular, we wanted to show in this subnetwork how the virus has been connected to unpaired electrons and brainlet waves, and about how these vaccines contain germanium and nanoribbons that scientists would surgically install into humans. And that is really the cause of this virus. Of course, there are anti-Semitic views as well, and racially derogatory views as well. So we see a lot of associations and conspiracy theories to the rich, the royalty, dictatorship, race. These are all very common terms. Biology seems like anything that a conspiracy theorist would be scared about, and in general has a high fear factor for when you don't know about what's happening. And these disparate entities are connected, and really they provide some valuable insight about what are the different contexts in which these conspiracy theories exist. And again, I just want to highlight here that the relationships are really good as well. So, you know, it's the frequency spreading the virus you see over here, and the virus penetrates, attaches to the cell, and the virus. Some say, you know, in the conspiracy theory world that it originated from a facility. It was a faulty practice under research. And this one here, the vaccine sterilizes Africans, is basically a reference to Bill Gates' massive vaccination programs in Africa, and his likely influence, according to the conspiracy theorists, in this massive vaccination and sterilization, quote unquote, campaign. And of course, you know, we have far-reaching influences across entities. This particular network is trying to show how nodes that you didn't think were connected actually are not separated by a very high degree. So you can look at Film Your Hospital, which was a conspiracy theory about how hospitals were actually empty without any COVID-19 patients. And you go just 4 nodes across and you see David Icke, who I initially mentioned, burned down, was attributed to the towers in the UK burning down the cell phone towers. So here's a slide for bias that I'm going to skip because we're almost there near the end. And here's like a quick coverage of the correlations that we can observe between news and social media. And in particular, this timeline shows how coronavirus and conspiracy theory have come together in the news over different time periods. So you look at January, you see that in the news, conspiracy theory and coronavirus didn't really have many connected nodes. This data, again, is extracted from a GDELT. Then in March, you see that, okay, these nodes are getting connected by various different actants. And then finally in April, oh, there are so many paths from coronavirus to conspiracy theory. And here's the last slide for us. It's the cross-correlation between communities that we have found in the news and social media. The cross-correlation is taken across time. The point of this graph was to see, well, hey, is there a lag between how quickly news covers a community and how quickly social media covers a community? And we noticed that the number of days offset between news and social media is very close to 0. Meaning that this feedback loop that I showed earlier is actually very quick. Information goes quickly from news to social media, back to the news, and it's cycled over and over very quickly. It may also mean that we're not targeting the right base sources. We are targeting places like 4chan, but maybe this conspiracy theory emerged in 8kun instead. So, you know, it comes with its caveats, but one thing can be said in that this feedback loop is quick. And some communities, as you can see here, the 5G waves, antenna radio towers, these communities are far more prevalent as a cross correlation between the news and social media than some of the smaller communities, such as, say, the virus emerging in a lab in Wuhan. Those were the results we wanted to share. Here are the references, and that pretty much summarizes our presentation. Shadi, would you like to add anything?
It was great, thank you.
Okay, thank you for that. That concludes it.
Thank you. Very fascinating. I have a couple of questions, but I want to let the audience ask questions. Please use the chat. If you have a question or just a comment, as you wish. Or maybe I'll start waiting for people to ask questions. When I read about conspiracies theories, they mentioned super conspiracy. It's like a superstructure. There's a hierarchy between conspiracies. How would you translate that to your graphs? Is there such thing, kind of, you know, the super one?
Yeah, shall I take that, Shadi?
Sure.
Okay. I'll say a little bit, and then maybe you can add to that.
Mm-hmm.
So, you know, there are a bunch of thresholds in which we can extract these communities when we create these networks of conspiracy theories. And these parameters that we use for this community detection can change the sensitivity to how disparate or connected these conspiracy theories would be. So for a much lighter threshold, we may not get as many communities, so that would create a larger community and may reflect, as you just defined, a super conspiracy theory. Shadi, would you like to add to this?
Yeah, and also our idea is conspiracy theories made up of connecting different domains, and we see the same. Some domains are pretty common across all these conspiracy theories, so it's like an element that they're trying to connect all those old or trendy ones to like the new events. For example, Satanism or all those different things that we see common across all these conspiracy theories.
And then when you use the data, you have the metadata or the admin metadata around social media, like the full. Did you study like part of the notes, not just the linguistic part, but the metadata origins, like the location, the GPS coordinate? Is it an iPhone or is it? So you would kind of get where it came from. Or that's another study, totally another study.
Yeah, go ahead, Shadi.
That's a very good point. We have the time stamps for these posts, but our general interest is finding the narratives. But potentially, it's among our future projects to include the network information or the metadata for each post, to consider like a history of where these relationships are coming from. Maybe it contribute to the fact that if we build a fact-checking system, that would also help us to consider the history of that person or the poster.
Yes. Yeah, but to answer again, to reinforce what Shadi just said, that's a great point, and we definitely want to include metadata into our knowledge graph, and that is happening as we speak in our lab.
Okay.
Yeah.
Nice. So you're building a fact-checked system? That would be very interesting. Like
fact checking is a little more difficult than just having a mirror out there that represents what we show. In social media, fact checking would mean that we have to then qualify it with an amount of trust about how sure we are that something is legitimate or not. We are not to that point yet where we have say a machine learning model that just runs on this knowledge graph and tells you whether something is trustworthy, whether it's not. But what we can say up to now is that the network that we create is explainable in the sense that every triplet that you see in the network is directly sourced from the data. But definitely that is also for future work.
So you can build a kind of trust score based on different sources, and some sources have authority.
Correct.
That's right. That's right. By fact checking, I mean highlighting those critical edges or those relationships in the whole picture, because we get a giant network. So our interest is to highlight the critical parts of this network, and then that would be easier for us to see if it like what are the most important noun phrases that are connected, so that we can use that whether we can fact check with some existing databases. So like we're interested in making it easy to compare to the existing knowledge graphs.
I think we have questions here. Steve, you can unmute and ask the question directly if you want to.
Sure, I'll do that. Thanks. So there was a slide where you had some entities who could benefit from this, and it was, sort of individual people being more critical, government entities. But the one that wasn't mentioned was journalists, and I thought that was the one that jumped out to me as you were describing, say, like, especially when you had that sort of layered structure with the conspiracy where you removed Wikipedia, and it just became patently clear how kind of fragile that whole conspiracy theory is, and it seemed like something like that would really benefit journalists, and they could really get ahead of the conspiracy theories in their stories and really kind of describe the whole context for them, rather than just sort of attacking little pieces, which is sort of all they're stuck with right now. Or like, what I see is journalists on Twitter, and they'll like quote something that's quoting as conspiracy theory and make fun of it. But if they could actually like sort of give it a broader context, I think that would probably be a lot more effective.
Yeah, there's so much data out there, and it's going so fast that at this point, selective data promotion is on its own somehow scary to think about. So having a summarization tool that's structured is definitely of use. Yeah.
Yeah, and then the other point I thought might be interesting would be like, how would, like, if you applied this whole narrative analysis to, well, I guess like a legitimate news story that was trying to deal, that was at least making a good faith effort to try to deal in facts, how would that be, like, what, you know, like, would that appear, would the network diagrams and everything appear very different from what goes on with conspiracy theories? And that could be really interesting.
Yes, in fact, that's a great point. For Bridgegate the project, we had news articles, and the resulting network was a big giant component, which was not easy to tear it down to smaller networks that we saw with the Pizzagate and WikiLeaks. So the newspapers and news articles that are not fake news, they tend to have like a much more connected network, like a hairball. And also we currently have like a daily basis data collection, and we see all these networks. In fact, some of the networks that we have in this presentation are very recent ones. And it's very interesting to look at them every day and seeing them updated and getting like bigger and complicated.
Did you find some kind of correlation between some conspiracy theories, let's say Bridgegate, Pizzagate, and now US Capitol, where US Capitol went out of proportion? We have literally domestic terrorism. Pizzagate, one person trying to kind of fix it on his own. Bridgegate, okay. What, like the early detection that you can really predict? And you mentioned, like, in terms of early detection for agencies, or for, you know, in terms of prevent crime and terrorism.
Yeah, I you know,
it's a hard one, but
yeah, it's a hard question, right? Because I mean, some may argue that you know, the Capitol riots were in some ways predictable already with all that happened just before it, with you know, the big speeches just before to rile up supporters and otherwise perhaps people who might create those riots and go march towards the Capitol. And indeed, there's an impeachment hearing happening about that right now. So it's a very complicated problem. We can probably do our best to provide knowledgeable and connected networks, but if we don't have public policy that is very proactive about it, I think it's a multi-headed monster, this one. And you know, we can't just say AI will solve everything, but we can try. Yeah.
Maybe my last question. Some conspiracies were like rooted in anti-Semitism, in racism for centuries. And also part of psychological warfare. Like, there are sources, they say like 5G was really by secret services of Russia. Like, how would you kind of also differentiate between the two? Something that kind of deeply evil versus, you know, it's part of the war. So it's fabricated using highly engaged social media, because the whole social media is, conspiracy theory is the best case for social media high engagement. So they found the right platforms to share those things.
Yeah, go ahead.
Right. Along all these data sets and all those, we see a lot of racism. There are a lot of like things that they bring the reason from based on racism that they have rooted in these conspiracy theories. it's a very interesting question about how we can see if this is from like a past racism or if it's something evil from those actions. But we see all these things that are pretty common in conspiracy theories.
Yeah, and to add to that, you know, we have seen this as well, and we've been trying to kind of classify between contextual threats and absolute threats, where you know a contextual threat, an absolute threat might be one that has had many contexts in the past, and at this point it's just absolute. Like you talk about an absolute threat, and everybody understands what that means. Like a direct racially derogative term would be an absolute threat. But having a contextual threat, on the other hand, would imply that there are actants around it that that really induce the threat. So there are definitely more nuances tied to absolute and contextual threat detection that one has to explore on these networks, which also is in works.
Okay. Thank you, everyone. Thank you again, Shadi and Pavan. Yeah, I learned a lot, and I hope also the audience. There are two links, two of your articles, very interesting articles published in Springer and PLOS One. So I kind of urge you to read them to get the full context of this. And thank you.
Thank you. It was a pleasure.
Thank you. Thank you very much.